Hey everyone, I am Miss Hu, your physics teacher. In this video, we're going to go through the concept of electrical energy and power. This is a topic that is in both the SPM and IGCSE physics syllabus. Keep in mind, of course, that this video is merely an overview covering what you need to know in order to answer the questions in your examinations. There is a lot more to know about this topic. So if you'd like to know more, please feel free to do your own additional research or watch my other educational videos. In the meantime, let's get started. Now, what we'll be covering in this video is just the formula that you would need in order to answer the questions in your examinations. So let's get right to it. Here's the formula. Let me move my face a little bit closer here. All right, so all you need to know in terms of the formula is this. The formula for electrical power is very simple. It's just the product of current and potential difference. I'm writing PD here for short, that's potential difference. So if we were to write this in the form of symbols, I'll use blue just to set this apart. Okay. If P was power, and I was current, and PD was written as B, you get P equals IV. I like to call this the poison ivy formula because, well, it's a cute way to easily remember this formula. Okay? So power equals current times potential difference, that's just P equals IV. Now, to get electrical energy, first of all, let's recall the general power formula, which you should have learned in another topic. Now, the general power formula, I'm going to magically show this, right? So power is basically energy over time. So if we were to rewrite this formula, making energy the subject, energy would be power times time. So if we were to write this using the symbols, I'm just going to use my pen to write it this time. Power, P, equals energy E over T, which is time. So if we rewrote this formula with energy as a subject, we get E equals PT. So why do we need this to find electrical energy? Because what we're going to do is we're going to combine these formula to find out how to calculate electrical energy using electrical quantities. So just to emphasize that we are going to be combining these two. Okay, and what we'll get is, in this case, okay, electrical energy equals electrical power times time. This formula is derived from this, where we know, okay, in general, energy is power times time. So if we were to focus on electrical energy, because if you recall, there's many different forms of energy, right? There's kinetic, there's thermal, there's gravitational, chemical. So focusing on electrical, if we take energy as electrical energy, this means that we should take power as electrical power. Time, of course, is just time. There's no such thing as electrical time, right? That doesn't make sense. So if we rewrite electrical energy formula this way, we get electrical energy equals electrical power times time. Now, we're going to take the electrical power formula and put it inside this formula, which means, okay, I don't have the magic reveal here, so I'm going to type it out. Electrical energy, which we can write as E, shift it here so that it's more in line. Electrical power is IV, so we're going to put IV over here, and time, of course, is T. And this is where we'll get the electrical energy formula, where we can calculate as the product of current, potential difference, and time, or E equals IVT for short. And that's it. If you have these formula, that's all you need in order to solve power and energy calculations for electrical circuits in your examination questions. So you need to know this formula, you need to know this formula, and you should be able to solve most questions. Of course, sometimes you would need to know this formula as well. So having these three, that's enough. But of course, I know that there are many of you who are wondering, okay, how on earth do we get electrical power as current times potential difference in the first place? So I'm going to show you how this formula is derived. Now, please keep in mind that whatever we're covering in this slide is not necessary for you to memorize to solve the questions. So this part is something you can skip if you like, but I'm just going to go through anyway to answer the questions that some of you have in your head, like where did this formula come from? So let's recall first what we have learned about current and potential difference. If you do not remember or have not learned the basics of current and potential difference, please watch my video where we cover the concept of current and potential difference in terms of the basic information that you need to know. So for this video, we're just going to go right to it. Now let's recall, current is the rate of flow of charge, which means that we can write the formula out for current, I as current, it's charge Q over time T. Right, so I'm just going to scribble here to remind you what each of these are. So I is current, Q is charge, and T is time. Now let's recall what we have also learned before about potential difference. So potential difference is the work done or energy used to move a unit charge between 2 points in a circuit. So in terms of formula, it's energy over charge. So V here is potential difference, which is typically written as PD for short. E is the energy used, and Q is charge. So combining these two formula, first of all, I'm going to rewrite this formula where I equals Q over T. I'll write it as Q equals IT. Why? Because we're going to take this formula and we're going to substitute it inside here. To make this easier, I'm going to rewrite the potential difference formula as E equals V times Q. So you can see from here, we can take Q equals IT and substitute it into E equals VQ formula, giving us E equals V times IT. Now, if you look at this formula, doesn't this look familiar? Doesn't it look the same as this? Okay, the I and V positions have changed, but they're pretty much the same. And that's how this formula is derived. And of course, if you want to calculate power, I'll use a different color just because. Remember, power is energy over time. So if we take this formula and substitute inside here, that's how we get P equals VIT divided by T, cut, and then you get P equals VI or IV if you swap it around. Okay, so that's how these electrical energy and power formula were derived. So just one more thing to go through with you. Sometimes you may come across additional electrical power formula and you're like, oh, where did these come from? So we know now that electrical power can be calculated as P equals IV. I like to write it in this form because poison ivy, cute, right? Okay, now there's another formula which we can use to extend the power formula, which if you recall, is taken from the Ohm's law concept. R equals V over I, which we will rewrite in the form of V equals IR. Why? Because this is an easier form to remember compared to this form. So that's why we tend to call it the VIR formula. Okay, so from here, let's say we combine these two formula. So we're going to sub V equals IR into P equals IV. So just because, okay, let me use different colors just to emphasize it, right? So we have P equals I bracket. Okay, we know V equals IR, so we're going to substitute IR inside V over here. And you can see you have I times I. So this is where we will get the P equals I squared R formula. So that's one derivative we can get from the combination of these two. Or we can rewrite this formula as I equals V over R. So if we were to combine this formula with this, okay, let's combine it here. So we will then substitute I into this part of the formula, which means that we will put it as V over R. And of course, we will keep V on the outside. So you can see over here now we have V times V. So that gives us P equals V squared over R, which is the second derivative of these two formulas. So I'm going to write here, in fact, I'm going to highlight it this way. And another one here. So these are two additional formula which you can use to solve questions. So if you're wondering when would you be required to use this formula, it depends on the question. Some questions may only give you, let's say, for example, the current and resistance of the component, and they want you to calculate the energy use or power use, or the other way, they give you only the potential difference and the resistance, and you need to calculate the power energy used. So you can use these formula instead of the original Poisson-Ivy formula, right? Also remember that you can combine this with the E equals PT formula. Let me write that over here. You can also combine it with, wrong pen. Let's try that again. With the E equals PT formula, which means you can also substitute this inside here or this inside here. So I'm not going to write that all here because this is going to be really confusing for you. Yeah, but just be aware of this formula. Now, if you find that there's too many formula to remember, you're like, oh my gosh, how am I going to remember so many formula? These are optional for you to remember. You can still solve the question using these two base formula. You don't have to memorize this, all right? So don't panic. If you have the brain space for it, go ahead and memorize it. If you don't, just know this formula and this formula and this formula, and you should be okay to answer most questions, in a straightforward way in your examinations. And that's the end of the video. Now, of course, if you'd like to know how to solve questions using this formula, I'll cover that in another video. But in the meantime, I hope you found this video educational and helpful. Don't forget to click like and subscribe for more lessons, solutions, and exam strategies from your physics teacher, Miss Ho. Happy studying!